Alright, this is going to be the quick number 28, review sheet number 28, quick video. So, try to get this one fairly short, but just help out on the ones that I know you're going to need help on. Okay, number one, I don't really think there's much help you need. If you need any help at all, you can look back to your learning target number 2 of your chapter 8. Okay, so it's just open dot, close dot, knowing which way, whether it's going to be greater than, less than, greater than or equal to, or less than or equal to. It's knowing which one of those four, and then the whole open dot, close dot thing. So go back to that video or those notes if you need to. Okay, write the inequality represented by each. Again, this is going to be learning target number 3. So chapter 8, learning target number 3. Any issues with these top two here, you need to go back and look into your notes, because if you go back there, it will help you. I really can't. I mean, these are. I really can't give you any more than that, because I'll be giving you the answer then. Okay, number 3. This was a percent question. This is actually chapter 6. Okay, this was chapter 6, as I was just saying. Okay, percent chapter. This was actually a test question. Okay, so you have to figure out what part of the shipment is basketball shoes. So basically, you got to think about this as a part to whole ratio. The part is representing the basketball shoes. The whole, since it wants to know what percent of the shipment, that would mean the entire shipment. Okay, so just keep in mind, you're going to have to add all of these. Okay, you're going to have to add all these together to get your whole. So this is going to be the total. This is just going to be basketball. And then when you know the ratio, so I'll write it over here, you know that the ratio would be basketball to total. There's many different ways you can do this question. You could set it up the percent proportion out of 100. That'll give you the percent there. You could just divide top divided by bottom and then turn it into a percentage. I would prefer the percent method here. But if you know the number of basketball shoes and the total, set up your percent proportion. That'll give you the percent. And then don't forget to round to the nearest tenth. Okay? Okay, more integer stuff. Okay, now, if you forget your integer rules, you need to look back to the review number 27 quick video. Okay, I'm not going to go over the multiplication and division rules. Okay, you can go back to that and you can find them, or you just Google multiplication and division rules and it'll come up and tell you. Okay, but I went over it. I think I've done it already on this quick video. I don't need to do it again. Now with positives and negatives, I will quickly remind you that the way that'll really help you on this one, I'll do the first one for you, is when you're adding and subtracting integers, you just got to look at them as integers themselves. And when I look at that 6, I see this. Because it's positive 6, I put 6 positives down. When I see this, I see 5 negatives. 1, 2, 3, 4, 5. And we worked on this when we went over review sheet number 27. You just look at it and say, well, what's going to cancel here? A positive is going to cancel a negative. 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 And we're going to be left with 1, positive 1. So if you use that method for addition and subtraction, it is really going to help you. Okay? Now the other one that I want to talk about is this one right here. Okay, this one's a little bit different. Okay? This one is something that you don't really understand yet. But I'm just going to show you how to do it, and then we'll talk about it when we go over it. So I'm going to give you the answer to this one. Whenever you're subtracting negative, what you're actually doing is you're adding positive. Now, I know that doesn't make any sense to you, okay, yet. It will, after we go over it, it'll make a little bit more sense, and then in 7th grade, you'll really know. So really, the problem you're doing here is you're doing negative 10 plus 10, okay? And then you can do your counters from there, okay? So subtracting negative is actually adding positive. Okay, so whenever you see negative, negative, I always just do this. I always just go ahead and put a little plus down through there, so plus, plus. Okay? Alright. Here, okay, this diagram shows how many pieces one 6-yard long Dion can cut from a piece of rope that is 2/3 of a yard long. So really what it comes down to is hopefully you know what type of problem. It says division would be there. Okay? Now don't worry about division equation. I'm not worried about that. I'm just looking for what division problem and then doing the division problem. So basically I'm looking for something, a number, divided by another number, and then that's going to, I want you to actually find the quotient, or the quotient, the answer to a division problem. Okay? So I actually want you to be able to tell me what that is to figure out what it is. And really the whole thing is just keep something in mind. When you have a division problem, remember it's whole divided by part. And obviously that gives you a part. So just think about it. What's the whole up here? Is it the 1/6 yard pieces or the 2/3 yards long yarn that's being cut from? Okay, so you got to think about that. Okay. Next one. Okay, we did one of these. I would need work here. We did one of these on review sheet number 27. Okay, there's two different ways to find the percent of this. You could just find 7% of 3260 and do that method, turn this into a regular number. Or you can do the proportion method, which is part over whole equals percent over 100. Okay, the percent for sales would be 7%, and then you know that the food always goes in the whole because we're finding the percent of that amount, and the of always goes in the whole. So either way there, you either need to have something like this twice, or you need to have two proportions. Regardless, we want to know what the total bill would be. That would include food, that would include tax, that would include tip. Okay? Alright. Next one. Okay, volume and surface area. Now, we talked about this on review sheet 27. I know a lot of you, for volume, are just going to do length times width times height. But I want you to get in the habit of using this formula. Now, remember, this is, actually I can just bring it up right here. Maybe not. Okay, never mind. Okay, the capital B represents the area of the base shape. So remember, the base shape is the one that's being stretched. So I'm just going to call the front my base shape right here. So basically what I want to do is I want to find the area of that front. Okay. Now hopefully you all realize that that's going to be just 3 times 6 because base times height. Okay. So that would be 18. Now we're going to multiply that by the h. Now the h here, the height of this, and the height of the prism are two different things. Okay, when you're doing this formula, and I know this is going to seem really confusing until we get to the chapter, then you're all going to think it's very easy. But when you're doing a height, you're basically saying, I want to know what the distance between the two bases is. So, in other words, how far is it being stretched? So basically, this distance right here is representing the height. That's the height. It's how far the front rectangle is being stretched to the back rectangle. So there you go. I basically just gave you the answer for that, for volume there. Okay, now surface area. Okay, now what surface area is its area of all sides. That is that. So you basically got to go through here. And the way I teach my students to do it, and when we get to this, once again, I think you guys will think it's easy when we get there. What I like to do is I like to make a list. And I like to say, find the area of the front, find the area of the back. Okay, that would be what I have in red there. And then the back would be that same rectangle. Then, find the area of the right, find the area of the left. This right here would be the right. Over here, that would be the left. Okay? And then finally, find the area of the top, which would be this. Oops, sloppy. The top would be this, and then the bottom. And if you find the area of all those sides, you just need to add them together once you're done. Okay? That's how you find area. That's how I teach it. There is a formula I could teach you, but trust me, you do not want to memorize formulas. I want you guys to understand how to do something, not just memorize a formula that you'll forget 2 weeks after doing the test. Okay? So as long as you know that all these are rectangles, so that means every area formula is just base times height, all you got to do is find the area of every single rectangle on there. Okay? Find them all, add them up. That's your surface area. Your area of all your sides or your surfaces. Okay? Definitely got to have work here. You're just adding, subtracting, and dividing fractions. Just one key reminder here, if you don't have this as 2 steps, then it's going to be wrong. So I really would need to see like 1 and 2, something like that. That's how I taught you to do it. Down here, I would prefer that you just went ahead and turned those to impropers, but if you didn't, that's okay. You don't have to. You have to here. Okay, but I have to see common denominators for these 3 there, and that's how you would do those. Okay. Here. Okay. Marcy planted 3 tomato plants in 45 minutes. At this rate, how long will it take her to plant 14 tomato plants? The big key here is this word right here. You have to find the unit rate. Okay. So you need to figure out per 1. Okay. If you don't do that, because I know a lot of you would just set this up as a proportion and do 3 over 45 equals 14 over x. That's not going to work. You have to find the unit rate. Okay, and you always want to find per 1 of whatever it gives you. So I'm getting kind of sloppy here. Since it gives you 14 tomato plants, you want to figure out how many minutes it's going to take her to plant 1 tomato plant. Okay. These 2 here, this is going to be 4 lines. So many lines you're going to need in order to get it correct. Okay, so just remember you're doing 1 step in rewriting every single time. Okay, and then this one, just keep something in mind. There's always that first step that you have to do before you do any math, and that is to turn that algebraic expression into a numeric expression. That is where you must start. And if you don't, then it will be incorrect. Okay? All right, let's go to the next page. All right. Here we have the same question that you guys have seen on several instances now. The biggest thing here, I want you to draw a picture. Okay, I want you to draw that rug. It's a rectangular rug, so I want you to draw it. Okay, you know that one of the lengths, in this case I would call that the base, that has that. You know this whole thing has an area of 35/4. Okay, I need to know what this is. Now instead of putting question marks, let's just put a variable, because that's what you guys know now. You understand how equations work. So you can set this up as an equation, no big deal, because you know that when you're finding the area of a rectangle, it's going to be base times the height. So this times this. Okay? But you're going to have to solve it because you actually know this and you know this. You do not know this. This is what we need to figure out. Okay? So you're going to have to set up an equation and solve. Okay, this question is very difficult. Very, very difficult question. Okay? What's really, really confusing about this is this right here. Okay? And it's kind of an unfair question, to be very honest. I really don't like the question. Most of you are going to do the formula I taught you. So area of the base times the height. So you're going to find the area of the base shape. So let's just say you call the front the base shape. Okay, you're able to find the area of that because you're going to multiply 4.5 times 3 3/4. And that's fine. And then you're going to do times the height, which is 5. That's the distance between the front and the back. And that'll give you an answer. But that's not the right answer. Because when you find volume, remember, what volume is I want to know how many of these, a 1 by 1 by 1 cubes would fit in there. That's what volume is. Just like area is how many 1 by 1 squares would cover something. Okay, volume is how many 1 by 1 by 1 cubes. So, the big mistake here is a lot of students want to just give me that answer, whatever that is. So 3 3/4 times 4.5 times 5, and they get some answer. But that's not correct because of this key. Okay? Because it wants to know how many of these would fit in there. Okay, you got to know how many of these would there be. Okay? So, when I look at this, if these were just regular 1 by 1s, if I did that, I would have 4.5 of them. Okay? Here's the deal. Basically, with all of these, you've got to take, before you do anything, you need to take each of these sides and multiply it by 4. Because you're going to have 4 more of those than you normally would. So you're going to take these and multiply by 4 to all these. That's going to give you a different number. Then you're going to find the volume of those, the new numbers. The new numbers. The new numbers. And I know that's really confusing right now. And this is, like I said, this is kind of an unfair question, but we've seen it, and it's been out there. So we're going to try to get it to you now, so that you have done it, so that you know how exactly to get it done. Okay, so that you won't be completely lost. You'll have a plan in place. So again, if you did 4.5 times 4, that would mean that would give you 18 of those across there. Okay, 18 of them. Because remember, this is 4.5 inches. Each one of those is 1/4 of an inch. So think about it. 1, 2, 3, 4 of them. That would be 1 inch. 1, 2, 3, 4 of them would be 1 inch, and then so on. And then you'd have 4.5 total inches long of those. So that's why we're doing that. This would be 20. This would be 15. Okay. So now you can do the formula: area of the base times the height. Okay. And I know that now I'm looking at it going, okay, then I just know that I can just figure out how many cubes there are, because I can say the area of the base. So if I called the front here my base, once again, to find the area of that base, I'm going to do 18. Let me draw that better. It's really bad. There we go. That's going to be 18 there. This is going to be 15 there, because think about it, that's got to be the same as those ones. So that's 15. So my area of my base is going to be 15 times 18, which is 15 times 18 would be 270, right? Then I'm going to multiply that by the distance between my bases. My front and my back in this case would be 20. So my area of my base would be 270. My distance between my bases would be 20. So I'm going to take that, I'm going to multiply it by 20. I'm going to get 5,400 of those cubes. So it's not true volume. That's what's a little bit deceiving about this. Volume would, if it just said here's a rectangle, find the volume, that would be trying to figure out how many 1 by 1, and that's terrible. Let me redraw that. There we go. How many 1 by 1 by 1 cubes? These are not 1 by 1 by 1 cubes. Those are 1/4 by 1/4 by 1/4. So that's why I multiplied each one of these by 4. Okay? But regardless, there's your answer. I did it for you. We'll work more with this when we get to chapter 11. Okay? Here we have a parallelogram. You know that the area formula for a parallelogram is base times height. Okay, now it gives you a key here that when you connect for those dots, that is 1 square unit. So if you went through here and connected them all, and so on, like that, it would look something like that. There we go. And then, of course, these and these. There we go. I just connected them all. Now, finding the area, the big thing is you guys got to remember that the base and height always has to format a 90-degree angle. Okay? So basically, I can't just count here and go, okay, 1, 2, 3, 4, 5. I can't do it that way. It has to be at a 90-degree angle. So I'm going to go see where it starts very at the top at a right angle, and I'm going to follow it all the way down. And that's how I'm going to get my base. So you got to count those, how many are there. Remember using this. And then wherever it runs into, that's going to be my other base. So you have to count that. Then from there, you'll be able to answer. Just remember to use the correct units. Okay? Now, I made mine really hard to read. Hopefully you didn't use pen. Hopefully you just use pencil so you can still see it. In the logo, they want to know what fraction this is. Okay, and I'm not gonna help you too much on that one. I want you to think about it as you look at that right there. And I mean, you could find the area of that. Maybe that would help. Or you can just visualize it, and you tell me what fraction of that entire parallelogram we're talking about right there. Okay, here's another strip diagram. You guys have been doing really well with these, so I'm not going to help too much on this. I think you guys can figure it out. You're going to use this strip diagram. There's your key there, and there's your real information. You can also do a percent proportion to check, but you must use the strip diagram in some way to find the answer. Okay? Okay, here's another cube question. Okay, if you were to take these, and we got to figure out the volume. So again, here's my volume formula. I've got to find the area of the base shape. So again, I could call the base shape the front, the side, the top, whatever you want to call it. I'll just call the front my base shape. So you've got to find the area of that. So this is the base, this is the height. So wouldn't you just be doing 3/4 times 1? Hopefully you're all saying yes. That's the area of your base shape. And then the height would be the distance between the bases. So since we're talking about how far it's being stretched, we're talking about this distance right there, which would be times 1/2. Okay? All right. What is the volume in cubic inches of one of the small cubes? Okay, so you got to figure out one of these cubes. So I'll erase this. So imagine you had this cube right here. 1, 2, and then it'd be even that part right there too, right? And then it would be, but you got to imagine that's 3D. So imagine pulling it out of there, redrawing it. It's not a very good cube, but you get my point, I think. There you go, that's a little better. Okay, if you were taking that right there, that's a cube. You've got to figure out what the volume of that is. Okay, so you're going to have to figure out what the dimensions of it are. So one of the dimensions would be this length. You're going to have to figure out this length, then you're going to have to figure out that length. Just by using this, you're going to use this distance, and this distance. So I'm going to let you guys think about that since it's multiple choice, but I think that should clear it up for you pretty well. All right, guys, I hope this helped.